Okay, in this presentation we're going to talk about how you make adjustments to your scope to compensate for different situations. In the previous presentation we discussed how to determine the distance to your target, and we talked about different types of scopes, first focal plane scopes versus second focal plane scopes. And if you didn't see that, you need to review that, and if you don't understand what kind of scope you have, it's very important regarding the next exercises that we're going to be looking at here. Here's a representation of your chart. Okay, if we look at the columns on the left side, this is a typical drop chart that you would see, and you can see that this is set up for a 300-yard zero. Your rifle should be zeroed for 300 yards. Now if we're dealing with the big magnums, those charts are set up around a 500-yard zero typically, but most of these charts are set up for a 300-yard zero. Each of these numbers on the left column represents a distance in 100-yard increments. So 1 is 100 yards, 2 is 200 yards, 3 is 300 yards, and so on. You can see that this chart is set up for a 300-yard zero, all the way down to 12 for 1,200 yards. Okay, and then the second column shows you the clicks that you need to put onto your elevation knob to correct for each of those distances. This is a typical drop chart that you would normally see, and this drop chart is set up in minutes of angle. Some of the charts are in mils for scopes that have mil-radian adjustments, and some are in minutes of angle. This particular chart is set up for minutes of angle. So if you were aiming at a target all the way out at 1,200 yards, you would have to put 44.9 minutes of up elevation onto your turret to make that adjustment for 1,200 yards with this particular combination of rifle and ammunition. To use all the features of this chart, your rifle needs to be zeroed for 300 yards. So you can see that the increment from 100 yards to 300 yards is 4 minutes of angle. So if you have a 100-yard zero on your scope, just go up 4 minutes of angle and then lock down that zero. Your rifle will then be zeroed at 300 yards, and you can use all the features on this chart. Okay, this next column shows you the increment in minutes of angle in between each of these increments. So this can be really helpful for rapidly determining the proper holdover in a lot of situations. So if you look at the very top, between 4 minutes of angle and 2.6 minutes of angle, the difference of that is 1.4 minutes of angle. So that's the increment in between each of these 100-yard increments. This column shows you the proper number of minutes of angle if you want to dial in for a 10-mile-an-hour crosswind. So this is what you need to dial in if you have an exact 10-mile-an-hour crosswind coming at 90 degrees. Some people like to dial in their wind, and this allows you to do that. Most guys are going to be looking through the scope with their right eye, and they're going to be looking at their chart with their left eye. So I have a representation of that here, and you can see on the right side of the reticle on the chart, you can see these horizontal lines that come off to the right with numbers 100, 200, and then 400, 500, 600, 700. Those are the holdover lines for each 100-yard increment, and this scope is zeroed for 300 yards, and that's why you don't see the 300-yard number there, but the rest of the increments are shown on those horizontal lines. The tip of those lines is equivalent to a 10-mile-an-hour crosswind. So you can use those lines for your wind adjustment as well as your elevation adjustment. Okay, I'm going to give you a few examples of situations where you would have to use holdover or Kentucky windage. Now, for these examples, you wouldn't be adjusting your scope on the turrets. I just want you to imagine pushing the rifle in a different direction to adjust for the environmental conditions or the different scenarios that I'm going to give you. So let's go to the first example here. Let's imagine that your target is at 300 yards and there's no wind. Look at the reticle on the right and imagine you're looking through your scope. And if this was the situation where there was no wind at 300 yards, where would you place the target on your scope in your reticle? Okay, your rifle is zeroed for 300 yards and there's no wind, so that is exactly where you would be holding, right dead center of your reticle. Let's go to the next example. Okay, in this example, your target is at 600 yards and there's no wind. Look at your chart and determine where you would need to hold to adjust for a target that is 600 yards away. Okay, you can see on the third mill dot down, that's where you would need to hold to adjust for a 600-yard target. Now the target is at 600 yards, but there is a 10-mile-an-hour wind that's traveling from left to right from the 9 o'clock position. And here's where you would need to aim. Now the target is at 150 yards, and once again we have a 10-mile-an-hour wind, and it's traveling from left to right. And that is where you would need to aim. Notice it's still a 10-mile-an-hour wind, but you don't have to hold very far away from your reticle. Now your target is at 650 yards and your wind is 7 miles an hour from right to left. So it's going the other direction now. It's traveling from right to left. Okay, here's where you would need to hold to compensate for these conditions. Now your target is at 675 yards. Your wind is 8 miles per hour from right to left. And here's where you would need to hold to compensate for that situation. Okay, in this situation, your target is at 600 yards. The wind is 10 miles per hour, but you can't use your standard hold because the wind is traveling at a 45-degree angle relative to your position from left to right. Now, most people would assume that the angle is 50% of your typical 90-degree angle, so you just divide by 2 for 50%. But in reality, it doesn't work that way. Actually, the wind has a little bit more of an effect than what you would expect at a 45-degree angle. So you have to adjust for about 0.7 of the standard wind adjustment. And this gives you the proper hold for this scenario. Okay, now the target is at 467 yards. The wind is 8 miles per hour, and it's at a 45-degree angle from right to left now. So it's going the other direction, but at a 45-degree angle. So you're going to take 0.7 of your 10 mile per hour hold, and then you have to take 0.8 of that. And this shows you where your proper hold would be for this situation. Now your target is at 580 yards. The wind is 10 miles per hour, and it's at a 30-degree angle from left to right. And here's your proper hold for this scenario. Now, if you assume that the windage adjustment would be about 50% of your standard windage adjustment for a 90-degree crosswind, you would be correct. It's about 50% of the standard adjustment. Thank you for your interest in Instant Ballistics products.